Hey, how's everyone doing today? So I am back from surgery yesterday. Yeah, let's do some sampling. Oh, that's some tough stuff. We'll do it here. So quick overview of what happened to Brian is started to have some pain this weekend and didn't sleep all Saturday night because I was up from pain. Haha, that's fun. And then Sunday night, I was able to sleep some, but had a lot of pain. But due to lack of sleep Saturday night, was able to sleep because eventually, even if you're in pain, you lay down and your body falls asleep for like 30 minutes and then you wake up. And so when I called the doctor's office on Monday morning, they were like, yeah, we need to get you in. It wasn't life threatening, wasn't going to die from it, but wasn't going to be able to sleep well or really be able to do much productively with the pain I was having. And so they got me in. So I'm currently on painkillers right now, and not like crazy amounts, but take my next one at 1 p.m. or so. But I'm trying to space it and use them as little as possible. It's funny, I had wisdom tooth surgery and didn't take anything. And maybe I just got lucky and surgery went really well. And this one seemed to go well too. But yeah, they got me in and they were like, yeah, we need to do surgery right away. And so yesterday had some little surgery. It's fun. Like, yeah, like, hey, it's Monday morning. Let's do a little surgery. Let's do some surgery. That's your everyday Monday morning. But it went well. Surgery didn't take that long, but not fun. What question do we have? So if I have to end office hours early, I apologize. I don't plan on ending it early. I don't plan on leaving office hours, but I can't promise if I start to feel sick or if I have other problems, I'll inform you. And I could literally just be like, I have to go. Bye-bye. I don't plan on doing that, but my apologies if there's a sudden quick end to office hours today. But that is not my plan. It's not my plan. It's not my plan to do. We will try to do... I'm going to try to do both. Try to do both. So, no end to office hours. Let's take a look at the first question right here. Oh, thank you so much, Miriam. I appreciate it. Yeah, I'm always afraid of like painkillers and stuff because there's a lot of issues people can have with painkillers. I'm looking up the problem right here as we're doing this in the background. I'm getting it working. So I'm taking them very cautiously. I'm kind of trying to like not trying to like. It says take 1 to 2 pills every 4 hours. I'm taking one pill about every 5 hours. So trying to like go for minimum dose so that way I can like not take painkillers because it's my first time ever taking such a thing. And I'll tell you, they do work. So, but be very careful with things like that. Thank you so much. I appreciate it, Kayla. Thank you. So yeah, doing a bit better today. Like I said, Saturday couldn't sleep Saturday night. Sunday slept because my body was like, yeah, you're falling asleep because you're tired. I actually fell asleep on the ground, like not like fell over, but Chelsea came out. She was like, "You gonna go to bed?" And I was like, "I'm asleep here on the ground. Just put a pillow and put my head on it." But yeah, anyways, doing a bit better. Surgery helped. Starting to feel better. On the mend. Let's do this. Let's hop into this question. Let's try 100 points. Mubot, you awake, man? Mubot, you doing well? Did you have surgery, Mubot? He looks to be awake. Mubot's here. We're gonna reset Mubot. Give it a lot of points. Okay. Let's do this first question right here. Stat 201. A restaurant has seats. Let's check it out. Here we go. A new restaurant has 128 seats. So immediately when you have these problems, what should you start doing? Yeah, of course. Let's do the soil ones. You know what's a funny kill? I like these way better. No, but we'll do the soil question next. Because those are tough. Those sampling ones, man, those are tough. So what should you start doing? Oh, let's do it. Let's try it out. What should you start doing with these questions? If you have a question like this, you should immediately start marking notation. What is this? Help me out right here. I'll do the other ones. Just start me off on, says it has 128 seats. Studies show, so this is the true proportion. That's maybe a tough thing to notice. Studies show that 62% of restaurant customers demand a smoke-free area. This is back in the day when you could smoke in a restaurant. And then in the bottom here, it says we want to go plus, says the mean plus 3 standard deviations. It's going to be important to the problem. So what is the first thing of notation? It says 128. So that's how many observations we're looking at. So that's the what of this problem. The key things right here will be notation. This is a tougher problem because it requires a lot of math, but hey, we like math. If you do the math right, the answer is always right. So we're opening a restaurant. We have 128 seats. So what's that in notation? We can do stuff like that here in a moment. You're right, Tiffany, but what is 128 in notation? It's just one letter. So what is 128 in notation? This will help us out, and I'll explain how we'll solve this. I do love math. If you get the math right, the answer is always right. So just think of one letter. Kind of looks like this or something. One letter for what 128 is. And then I'll show you the mathematics we'll be doing to solve for this. So what is 128 in notation? Because it says we have a restaurant with 128 seats. That's the sample size. So it's N. Kayla, great work right there. You got it. So that's N. So now what we have to know is we need to understand what the mean and the standard deviation are for this distribution. And once we find these things out, we can solve that equation of the mean plus 3 standard deviations. Well, the mean, that's good. The mean is going to be, and this is for categorical data, because we're asking, do people want smoking or do they not want smoking seats? And so the mean for the distribution of p hat. So this is what we expect when we take a sample proportion. What do I mean by that? If I have 128 customers come into my restaurant, what proportion of them, because that's a sample, what proportion of those customers do I want to want smoke-free? So we're saying the expected sample proportion. Like you have 128 customers walk in, what proportion of them would you expect to want non-smoking? And so what the mean is equal to, it's equal to P. Think about this. 62% of my customers want smoke-free area. So if a bunch of my customers walk in, what percent of a sample, like 128 customers walk in, what's your best guess of the percent of them that want smoke-free? 62%, we know from data that 62% of people want smoke-free. So if a sample were to walk in, just random customers, what would you expect from a sample? Like we know from history. Why didn't you? Because Y bar will be for quantitative. Great question right there, Kayla. I could show that too. Y bar will be quantitative. So this one here is a categorical question, so we'll use P. And that's such a good notation question. That's where it gets a little bit confusing. I might even show the second way, the other sorts of problems. Sorry, I'm going to readjust a lot to not be in pain. You might see me do this a lot. So what, just think about this. I'm going to ask a few questions here because this is the conceptual stuff we need to make sense. 62% of customers want non-smoking. Bunch of my customers walk into my restaurant. What percent of them do you think want non-smoking? So don't worry. This is what sometimes doesn't make sense to people. This is saying, what would we expect from a sample of our customers? So the mean is the expected value. And this means from a sample proportion. Like if we had a sample proportion, what would we expect? And so for this problem, if we're saying we know 62% of people want non-smoking, what would you expect in a sample? If you took a sample of customers, what would you expect? If 62% of people want non-smoking, then if a bunch of people walk into your restaurant, you would expect what? So we know 62% of people want non-smoking. It's not meant to be complicated, I promise. Just think, I know 62% of people want non-smoking, so if a bunch of people walk in, I'd expect what percent of them to want non-smoking? That's what this equation is solving. It's more complicated with the notation, but it just says the expected sample proportion is equal to the true proportion. So if we know 62% of people want non-smoking, then guess what? We would expect to see that in a sample. Does that make sense? We would expect to see that in a sample. So we're saying we expect in a sample to see 62% because that's the truth. Now, the standard deviation is the more complicated one. The standard deviation of a sample proportion is equal to P times Q over N square root. Because think about this. Is exactly 62% every time going to be the answer? No. There's going to be some sort of variation in this. Here's where the variation comes from. Because every time people walk in, it's not going to be exactly 62% of them want non-smoking. There's going to be sometimes 61, 63, 64, 60. There's going to be variation in what percent of these random customers want non-smoking. So to do this, we have to plug in P times Q over N square root. And so we didn't get to have lecture yesterday. I sent out the video, but P and Q are complements of each other. So I want someone to answer this 100-point question. If P is 0.62, what is N? If P is 0.62, what is N? I mean, we'll just Q. What is Q? If P is 0.62, what is Q? P and Q are complements of each other. N will be 128. I think I said what is N? N is 128. And Q is the complement of P. So what is Q? So if P is equal to 0.68, Q is equal to what? They're complements, which means they add up to 1. So if you're wondering what a complement means, it means this plus something else adds up to 1. So you can subtract from 1 to figure them out. But what is going to be the complement? 0.38, 0.32, 0.32, 0.32, 0.32. And that's just because they add up to 1. If you want to double check your work, always just take and great job, Tiffany and Kayla right there. Yep. Just make sure sometimes make a decimal error. Don't worry though. Don't worry. I said some points right. So there's some points right there. So there is the complement right there. And so we just plug in the number. Oh my God. No, you are correct. Did anyone else catch that? No, that's right. Okay. There we go. No, you're right. I don't know why. I think the 128 and things like that were blending in my mind. Now my ear's acting up. It's one of those crazy mornings. I made a mistake right there. Does that make sense? I put in the wrong thing. Brian can't math. Now my ear's acting up. Oh my gosh, things are crazy. You will times them together. That is correct. P times Q over N square root. P times Q over N square root. You'll hear me that repeat a lot. I was like, exactly. You're like, what? Wait, this is what's going on here. There's your P, there's your Q, there's your N, there's your square root. So we just need to solve this right here. P times Q over N square root. I think I didn't hit anything wrong. There we go. And square root. Don't forget to square root. And that's the standard deviation, 0.043. Okay. So now we're going to do how many of those standard deviations? And then we're going to add that to the mean. How many of those standard deviations do I need to do? So I need to do how many of those standard deviations right here? Devood. Oh my gosh. There we go. 3. And this is basically going up from what we expect and going up 3 standard deviations to say, well, here's the upper end of what we would expect. So we can visualize this too. I'm going to visualize it here in a second. Mubot, where you at, man? Mubot's got right here. Okay. So the standard deviation is this. And then we're going to put the standard deviation here. And we'll do this. And then we put the mean of the distribution, which is this. And there we are with what it looks like. So really, understand this right here. We expect 62% of our customers to want non-smoking. But with random customers who walk in, it could be like 66%, 70%, but it probably wouldn't get higher than what? Like going out 3 standard deviations, which would be very unusual. We probably wouldn't see, and just round this to a nice, neat number. We won't round it yet. But we probably wouldn't see more than this percent of our customers demanding non-smoking. Like random customers walk in, we'd expect, my whole body's falling apart. We'd expect 62% of them to want non-smoking. And this would be very unusual. Like this is what we expect. It's like, yeah, 120 people walk in. I expect 62% of them to want non-smoking, but 75% would be very unusual. And that's 75% of our 128 customers, I think it was. So let's times this of 128. We're just timesing that number we got a second ago times 128, and we didn't take it. Sure. Here we'll times this by 3. I'm gonna do it this way. Let me show you with the mathematics on the screen because I'm slightly confusing myself. I could show you that way, but I want it to make sense. Let's take the mean. The mean is this. Does that make sense? There's the mean. We're just taking the mean. Now we're going to add to it 1 standard deviation. 2 standard deviations. And 3 standard deviations. And take a look at what we have. We have the exact same answer that we visualized right here. Does that make sense, Kayla? I went to the mean and I went up 1, 2, 3 standard deviations. So you have to find these values. What is the mean of the distribution? What is the standard deviation? Go to your mean, which is 0.62. There's my mean. And then add to it 1 standard deviation, 2 standard deviations, 3 standard deviations, and now you've done the mean plus 3 standard deviations. Now that we have this is the highest amount of percent of customers we'd expect to want non-smoking from a random sample of 128 customers. So now all I have to do is multiply this by 128. And then here's the biggest thing. When you do this, you must do this. This is where people make a mistake. You must do what with whatever number you get. With whatever number you get, this is where a mistake happens. You must do what? What must you do with whatever number you get? You want to make this is where a mistake happens. A lot of people get this wrong because they make this little error. My gosh. What must you do with whatever number you get? Whatever the number is. As in, if my number was, that'll be 96. But if it was 95.1, what do I do? Exactly. Make it a whole number. And to do that, you're correct, Kayla. And so what will, pretend this is my answer. Pretend this was my answer. Would this be 95 or 96? So make sure to take note. You get this answer right here. This is where a lot of the mistakes happen on this problem. So you get this number, 95.1. The mean plus, and I'll show again, Tiffany, right here. So what do I do with this? It'll be 96. And so the numbers we're using, I'll write them on the, thank you, Tiffany, for asking. We'll write them down here on the bottom. So remember, the mean is, we're going to solve the formula, the mean plus 3 standard deviations. And then we'll times this by the sample size. And so the mean is 0.62 plus 3 times 0.043. This is equal to basically 75%. And that, let me vanish. And then we will take and multiply the 0.75 times the sample size, which is 0.75 times 128. That is equal to 95.8 or so. And then we're going to round up on this, whatever it is, to 96. Exactly. We don't want to be, exactly. That's kind of the concept behind it. You're right, Kayla. Kayla, excellent work. Great comments right there. You're exactly right. That's why they're doing it on this one, rounding up. And does that make sense right here, Tiffany, on the steps to do this? We found the mean. We found the standard deviation. So the mean and the standard deviation are found. There's the mean being found. There's the mean. And the standard deviation right here is found right here. And this is the same conceptual thing we're doing up here. So that is kind of all the mathematics worked out for this. And so we should put in 96 right here. And short question, long work for it. Check answer. Yes, got it right there. So one last thing to comment on with this is this was all for categorical data. So can you take the square root of, because I keep oh yeah, so you only, yeah. So make sure, here's the way to do it. Here, watch this, you ready? P times Q, there's P times Q over N square root. And so there's that, there's what that is. Let's multiply this times 3. There's that, that's 3 times it. If the mean is 56, let's add that to 56. There's 3 plus it. And then let's times that by 129. Your answer should be 90. Make sure to round up. Double check your work. Yeah, let's do that next, Snea. You got it. We're going to do another 201 here in a second. And then Snea, you got it. Thank you so much, Snea, for showing up. More crazy points this morning. I'm going to get my second cup of coffee here soon. So as long as we're doing all right-ish. Got that energy right now. Got that energy. But my ear's acting up. You go to an ear doctor next. Who knows? But this is, you should get 90 right there, Tiffany. Double check your work. See if you work it. See if you get 90. Should be correct. And so One last thing I want to mention on these problems is the problem we just did here is categorical. There's another portion to this, which is quantitative. And if you're doing quantitative problems, the rules change. We have right here, the mean we expect from a sample is equal to the true mean. And then the standard deviation. You're welcome, Tiffany. Excellent. Great job. Thank you, Tiffany. Appreciate it. I love it. Kayla, Tiffany, Snea, you guys are always here. And I appreciate that. Guys, I think everyone's gals. But you know me, I'm from New York. So I say guys. Everyone's a guys. So this right here is if you have a quantitative. And this is the expected mean. Like, let me say this. The average UT student has a 3.6 GPA. You talk to UT students and you get a sample. What would you expect the sample GPA to be? So expected sample mean is equal to the true mean. This is more of like an expected now. So if I know that students have a 3.6 GPA at UT and I take a sample, then I'd expect it to be 3.6. Now the standard deviation or the variation in a sample mean would be equal to the original standard deviation over the square root of n. And so that is the new standard deviation for a sample of size n. And this is all for what kind of data? Remember I said the GPA, this is all quantitative. So quantitative, I think that's how it's spelled. We don't spell things in statistics. So this is slightly different, but please note right here the difference between quantitative and categorical, where in quantitative, you'll do it this way. Here, I'll put them both on the same screen. Quantitative is this way, and then categorical. And these are great notes to have. Categorical is going to be the mean for a sample proportion is equal to the true proportion. And then the standard deviation for a sample proportion is equal to P times Q over N square root. So you have to ask yourselves, and let me ask you this, you ready? Review question right here. 1, 2. If Brian measures the heights of students and he's trying to look at the true mean versus the sample mean or whatever, would I use equations 1 or 2? If I'm trying to look at what I might expect to see in a sample of heights of students, oh yeah, we'll do it here next. Would I use 1 or 2 for this? Would I use equations 1 or 2 if we're doing heights of students? If I'm doing heights of students, would I use equations 1 or 2? And this is very important because if you use the wrong equations, the problems just go haywire. So would I use equations 1 or 2 for heights of students? Equations 1 or 2 for heights of students. So we're doing something with heights of students. Would it be equations 1 or 2? It'd be equations 1 because it's quantitative. Now, Tiffany's question says 13% of people will not make loan payments on time. Like you either make your loan payment on time or you don't make your loan payment on time. So Tiffany, if you want to start this one, we'll take a look in a second here. Would you use equations 1 or 2 for 13% of people don't make loans on time? And Kayla right there, excellent, more points. Would you use equations 1 or 2 for Tiffany's? Hey, Roger, good to see you here. We're going to do some 474 in a moment. We're going to do Kayla problem, then we'll do 474. Would you use equations 1 or 2 for Tiffany's with bank loans where people either pay them on time or they don't pay them on time? So that's the way, because either you pay your loan on time or you don't pay your loan on time. Be careful. We'd use equations 2 because we have the percent of people who pay them on time, which is a proportion. So because it's categorical, do you pay your loans on time? So people either pay them on time or don't pay them on time. It'll be a categorical question. So that is how that one is done right there. Number 2, exactly. So we will, Brian spaces out half the time. That's got it. Here, let's go back to the main screen. So really good practice right there. Like practice up on that. Cliff, good to see you here, Cliff. 100 points, everybody. Let's go check out a problem 10. Then we're gonna do some 474 and then we'll come back to 201. For some reason my mind's more focused right now. Got that focus right now. Gonna get a second cup of coffee here in a bit. Okay. Chapter 10, quiz, environmental agency. Ooh, I'm gonna need some help on this problem. These are the toughest ones because it's very exact. And I'll need to find this. What they do... Oh, I will. Yeah, I will. Thank you, Roger, so much. Yeah, I'll probably be laying down tonight and stuff. So if I'm slow on emails, everyone, I'm very sorry. I'm operating at like 50% energy. Thank you so much, Roger. I really appreciate that. Today's my first time having coffee in a while. Since like Friday. It's a while. Oh, Mob Pearson, why you do this to us? All the rest. Okay, this is not the environmental agency one. The way they do these is these like change, like questions will change what they even say. Like waited outside a bar. If you notice, like this one changes. And so we have to find the question you're taking that will change. Oh, wait, I think we got it. This is an organization. We will find it. This is the amusement park one's always amusement park. It's on. Yeah, the environmental agency. That's always the parent plan one. That's the bias, the question bias one. Oh wait, I think it was car dealership. So they literally change what the question is, like drinking and driving, pollution. Where's the environmental? This is the top business question. They really make it so hard to find. This is always. Can you put the start of the question, Kayla? Let me try again. We'll find it. We'll listen to one more song here. We can find this. Let me listen to my favorite song. Where's that song at? No, this one. There, cool. I think it's hard to find these problems. A soil sample. Yeah, they're doing like soil samples at the environmental agency, right? They're like, I'm literally showing like tons of answers right now. I think it's this one. So, okay. No, it's not. Okay, one more. What are these longer ones? This is it. Environment change. How am I just not finding it? Okay. It's population views. It's so, this is like, I always hate, like there's so many versions of this. It's the magazine one. Did you see it change? So watch, do you see how this one says right here, a magazine interviewed these people, and they do this, and eventually you get a version. There it is. Here we go. Let's take a look at it. So once again, I can't solve this problem without looking at it, without the answers, because it doesn't give me a version of it. Love you, Chapter 10. You're the best. Let's go check this out. Okay. We found it. After a long trial right there. Okay. So the population is all people or things we want to understand. So we want to understand soil around a former toxic waste dump. Awesome. And so pretty easy right there. And what is the population parameter of interest? This is probably one of the hardest questions to answer right here, because I think they say, but it's tricky because I've definitely done like a proportion, which you might think it is. But when you do this right here, where do they say? Environmental agency took a sample of 20 locations near a former industrial waste dump and checked it for evidence of toxic chemicals. Now, they don't tell you what this is. They found no elevated levels. So that's kind of a hint right here on what the parameter of interest is. They're looking for the levels of toxic chemicals. So they found no elevated levels. We're not going to look at the answers right yet, but here we go. What is the sample frame? Now, I'll put answers in the chat. I'll tell you my answer here in a second. But they're taking soil samples around this former toxic waste dump. And so what is the sample frame? The sample frame is all people or things we have access to sample. So think about what is the sample frame right here. What is the sample frame going to be? What is the sample frame going to be? What they have access to. So any soil they could possibly take. So if you look at the answers right here, like this might, the sampling frame is all soil. Well, they might not have access to all the soil. The sampling frame is the location of the samples. No, that sounds like the samples. The sampling frame is all accessible soil around the dump. So maybe there's portions that are like locked off or we can't get to, like restricted areas. So once again, it makes sense with sampling frame, probably one of the easiest answers right here if you know what sampling frame is. And like we said, it's everything we have access to. Good to see you here, Avery. Let's throw out some more points to everybody. Class not over. So all the soil we have access to. Pretty, I like that one. That one makes perfect sense. What is the sample for this study? Well, what do you think we're going to talk about when it comes to the sample? What number should you probably see appear? Just put a number that if we're taking this many location samples, then what should probably appear in the sample? Like, probably should have this number in it. The 20 samples we take. So there it is right there. The 20 samples we take, like the actual things we take is going to be the soil samples. So that'll be the actual ones right there. What sampling method was used? Doesn't really say. Love it. Cool. We were right. Doesn't really say. That's about the best we can do right here. It doesn't really tell us much information about how it was taken. Just 20 samples were taken. So it's not really clear right there. I hate it when it's not clear, but sometimes people present things to you that way. So sometimes we get a question that way. Is the sampling method used random? Well, if it doesn't say, it doesn't say. So I don't know. So that's, once again, we really don't know. Does that make sense, Kayla, right here? This question is lovely for that reason. But it wasn't clear what sampling method they used. It's not clear if it's random then. So it's like, I don't know, which is a perfectly fine answer if you don't know. So good stuff right there. What was left out of the study? If there's any restricted areas, yeah. Let's see what the other answers are. No, this is not the soil. The soil, no, we're not interested in this. The locations near the waste dump that were not chosen. So people might say this, well, what about the ones you didn't choose? When you take samples, you wouldn't, when we say something's left out, it's when we say, I feel like I didn't know more than one. And I was like, surely, yeah, I know, right? Because sometimes this is a tough one. And it's like if I go to the library and I speak to students, the students I don't speak to in the library wouldn't be left out of my study. They would just be people I didn't select randomly. So you don't want to say that the soil we didn't choose was left out. Farzan, good to see you here. Farzan, some points for everybody. You wouldn't want to say, Brian is sus. Brian's very sus today. He's on painkillers from surgery. Fun times. You wouldn't want to say that they were left out. You just didn't include them. Is that left out? No. Left out implies that we should have included them, but we didn't. Like if we didn't go to a certain area, then that would be left out of our study. What type of bias in this is evident? I don't think we have any bias. Yeah, thank you, Farzan. Appreciate that. So I didn't see any bias. Who knows? Maybe there is. What problems can you see in generalizing to the population of interest? I don't see any problems. So I wish it could be more clear. I would actually maybe say I'd like to know more information on the sampling process. Was it really random? Or did they just do it voluntarily? Or did they go to the convenient samples, the ones closest to them? Like, did they really randomize the locations they took? Which it's not clear. So I do have my qualms with this question. Does that make sense, Kayla, right here on how to do these and what this all means? That should do it. Hopefully that makes sense. Tougher question. A lot of them are more specific. It's probably one of the toughest ones. We got the free pass on it where Brian didn't make any errors and showed a bunch of answers. So good stuff right here. Make sure to practice. Know what these terms mean. Like undercoverage is when you leave out a certain voice in your population. Response bias is when the question wording or the researcher's behavior influences the way the responses are. Voluntary response bias is when people who volunteer differ in the responses than those who don't. Or like we pull in volunteers, which are going to have stronger opinions. Undercoverage bias is leaving out a voice again. Like we only talk to freshmen, so we left out sophomores, juniors, and seniors. Non-response bias is when those who respond differ in their response than those who do respond. It's like doing telephone surveys and people hanging up the phone on you. If for some reason people are more suspicious of telephone surveys and you're asking things like, maybe your telephone survey is, do you trust the government? So I want you to think about this, Kayla. We do a telephone survey and the question is, do you trust the government? People, and I swear, especially talked to my parents this weekend, my dad got a call saying there was a warrant out for his arrest. And he called the person back and was actually like, I'm fine with saying it. He needs my dad. I love my dad, but I actually called the police department and they were like, no, sir, that's a scam. And I was like, I was 99% certain it was. And then I three-wayed the call with my dad. I'm trying to remember what this example is for. Oh, yeah. So it's non-response bias. My dad is one of those people who will answer the phone and talk to people. And he's a little too trusting. Love my dad. But so the people who respond to you might differ in the ways than those who don't. So if you do a survey and ask people, do you trust the government? The people who answer the phone and say they trust the government might be more, I'm not saying I don't trust the government, but they might be more like, does that make sense? There's a bias in those who respond to you to be more trusting. So that's a problem. It means your survey doesn't generalize. Let's head back here. What happened yesterday? I had surgery yesterday morning. Woohoo! Love surgery. Don't love surgery. Doing better-ish now. Oh, it's too hype for me. So if I have to go at any time during this, I'm sorry. I'm on painkillers right now. Yay, painkillers. Please use responsibly, and I'm taking lowest dose I can. They said 1 to 2 pills every 4 hours, and I'm taking 1 pill every 5 hours. So trying to minimize and not take a lot. But no hydrocodone plus Tylenol. I think like 375 and 0.75. If anyone's a pharmacist here might know. That's like 375 milligrams. Model plot wasn't shown on number 1, 475. Oh, we'll take a look. So is this, we're doing 470. Is it, Snad, did you want 474 number 1? We're going to do that in a question over here. Which one is it? There was another, it was a 474 question 1 or 475 question 1? It was 475. Yeah, let's do some 475. Now my ear's acting up. Also, number 2, doesn't matter which transformation. Is there an office hours for project 1? Yes. I can send you that. I'll find it here in a little bit if you want. We did some office hours for project 1. And yeah, you bet. We'll do some chapter 13. Okay. Let's check this out. Let's get the assignment. Great job, Snea, working on this assignment. What do you think about the assignment so far, Snea? Not too bad. Let's see why the autoplot's not working. Do a little bit of the assignment. I've got the answers if I want. Decomposition. Grader said they should be caught up here like today or tomorrow. I got the rest of the grading done. Okay. Let's take a look at some 475. It doesn't look too bad. Awesome. Yeah, I didn't think it's too bad. A lot of questions, but a lot of repeat type stuff. Let's take a look at some 475 chapter decomp question. Let's do it. Okay, so make sure you have FPP3 loaded up, and the seasonal is going to be used to make some models. Make sure, here's the thing, if you have to install these things, do not. The question is asking you to use the autoplot on the GDP per capita for every country, but the autoplot is too big. Oh, did I do that? Ooh. Yeah, it probably is. Let's fix that. Install this, but once you install it, make sure to comment it back out. Please make sure to do that. Consider the GDP information of global economy. Plot the GDP per capita for each country over time. Which country has the highest GDP? Let's find out. Okay, let's see global economy. There it is right here. And let's look at how many. There's a quicker way, right? You know what we might be able to do? I have an idea. Let's try something. Okay. No. Thank you so much, Kayla, right there. Kayla, you are amazing. We're going to move that legend. I want to remove the legend. Don't want to hide the legend. I want to remove. No. Let's see if we can remove that legend, Snea. Should we find the country with the highest GDP per capita? That'd be fine. That'd be fine. Oh yeah, no, you're fine. Autoplot is coming out of the autoplot right now is in the forecast package, and here it is. ggplot autoplot. Oh, remove the legend. Yeah, I think you're right. It's gonna make way too many. Oh, my brain's not working this morning. What? There we go. Whoa. Objects of type numerics, not what's going on? Global economy. Is it still creating that plot right here? I've broken everything, Snea. Might go cheat and look at answer real quick. This is a Tizble, right? It's a Tizble. So we should be able to do. Let's go right here. Let's take global economy. Let's pipe it into autoplot. GDP. Okay, that works. I think it's an argument I'm supposed to be using. Okay, it's fine. Okay, so it's going to make the crazy plot right here. We should be able to do select. So that's crazy right there, right? Okay. Should be able to go right here and go select. And then country. Oh my gosh. Define which max fund the country. Awesome. Yeah, do that. That's awesome. Oh my gosh. Brain is not working. Using select dplyr. Too many codes to remember. Oh, that selects columns filter. There we go. There we go. Ooh, missing data? What's going on right there? Oh, nice code, Snea. Excellent work. So we don't want to do select. Select selects columns. We want to use filter. So Monaco has the highest GDP? There we go. Really? That's interesting. So Monaco has the highest GDP right there. And we should, if we want. Yeah, might need to put an update. Like just say plot a few countries right here. Let's put this on a new line. Really? Is it mad because of the... Trying to get it to a new line. There's the indent I wanted. Okay, cool. Okay. It's going 7 in. And if it's a country community autoplot. Yeah. That's what we want to do. So we should see 2 on here now. Oh, we're missing a closing. Let me get out of that. Open, close. There we go. There we go. That's so interesting. Why is Afghanistan missing data on those areas? Can we put USA on here? Whoa. So wait, double check. Snea, I don't know if your code is finding the country with the highest GDP, because right now the USA is dwarfing everything. So let me look at the code right here. Global economy country, which, okay, let's look. Oh, because we're doing, we have to mutate it per capita. Okay. I made, you're auto-plotting GDP. Yeah, we need to go per capita, right? So you're right. Yep. I remember now. Yeah. So what we can do is we can mutate this. So we could find this out ourselves. There's a lot of ways to do this, but Brian's going to try to remember how to use the mutate function. So what we want to do is we want to mutate I'm going to go here and mutate GDP divided by, and so let's look at the variables again. Population. Okay, there we go. And that should get us, is it 9 mutate, and then restore mutate. Oh, we could just do it in the autoplot. You're right. Well, that's nice and neat right there. Let's just take that. Yeah, why do it in the mutate when we can just go here to the autoplots? Ned, you are on point right here. Throw in that autoplot. Oh, look at that. Looks totally different. There we go right there. Throwing in the autoplot looks totally different. So you are right. We should be able to throw a mutate on and store it. So let me get the mutate and storing. Mutate and store in dplyr. Create and modify. So here we go. Mutate. Show me examples of mutate. There we go. Okay. So we need to go here. So let's go here. GDP per pop equals this. That's why it didn't go. And then there we go. So you can do this right here. It's always so many things, remember. So you're just storing this right here. And then what we could do is we could mutate this. So we can mutate this. We're going to put this on a separate sub-indent line. We're going to go here. And then we're going to select certain countries. Or not select, that's select columns. Filter countries within our vector right here. And that's the concatenated vector. And then we're going to take, and yeah, that's the way it should look. No, it doesn't matter as long as you get the same thing. There's a billion ways to do it. Because you could just store the column on, or you could just do it in the, like you did it right there. We're going to get the same result right here with the autoplot. It's just that now we've created this variable. Maybe if you're going to be working with this data set a lot, it could make sense to make a variable. Does that make sense, Tanea? Like, reasoning for this is if you're working... Brian moves. If you are... if you're working with a data set a lot, then you might want to store variables on it, and the mutate's going to do that for you. If you're working with a data set just like once, you might just run your equation like this. So this is more of a quick fix, which is fine. You'll see me do that a lot. 100% valid to do this. This is more like I'm going to be growing this data set and appending new variables to it. So yeah. So either way is 100% fine. Let's do another little bit here. Let's put 5 more minutes on the clock. What else? So I might need to update this question and say plot a few of the countries, plot the one with the highest GDP per capita, because plotting them all is going to be ridiculous. Yeah, I think this is the only time it asks for GDP rate. Yeah. Yeah, so you could do that, exactly. Snea's solution, another 100-point Snea right there, especially since it's the only time. You might just do it right there, because maybe you don't want to just keep track of this, which not like, oh, you don't want to keep track of it, but if you don't need it for future use, it might just be like a one-time thing. So this is more of your permanent solution, and this is more of a temporary, just like I'm just going to use it one time. But both get you to the same answer, so tomato, tomato. On number 2, does it matter what transformation we choose, if any? For each of the following series, make a graph of the data. If transformation seems appropriate, do so and describe the effect. Show both the series and then transform the series comment. Hey, let's do one of them. So United States GDP for global economy. So once again, we're going to take a look, and we're just going to use the same sort of stuff right here. So let's take global economy. Let's pipe it into a filter, country equals United States. And so there we go. Double check your work. Never hurts to run something. Auto plot. And an auto plot, of course, the GDP. And there it is right there. Looks to have a little bit of exponential growth to it. No, not real cyclical right here. So what I'd probably do, and this hints, looking at the data, looks, little weirdness right there. Got some exponential. We'd really like this to be like linear. That's going to be like the best if it's linear. So it's features, Guerrero. These codes I have to remember. But Snea, we want the features, Guerrero, however you say, probably the gentleman's name who made it. Let's go back here to the decomp notes. Never hurts to cheat and look at the notes. And so we're going to pull the decomp notes right here. And we're going to grab the features. Here it is, feature, and we're going to pipe it through. So we're just going to literally take this code right here. And back. And so now maybe you could square root it. Just remember what the good thing is that this code right here, don't like it looks like that. Global economy taking through there, and we're taking the GDP variable, and you could square root it. Oh, we need to filter United States. It got mad at me for all those. Why is the filter sub-indented? I don't like that. There we go. Here we'll take a look what happens if we were to change this. And so that's the lambda transformation right there. So that's the suggested lambda transformation. And so this is going to find you what it believes to be the optimum lambda transformation. I think some of them might have issues because the time series is missing data points. So now to use the optimum lambda transformation, we have to do this. So we don't need the change of the axis. Doesn't hurt to put those things in. Square root, we could square root. Let's square root 2. So now we're just going to take pipe through here, and we're going to take the value of the Guerrero lambda. It's the optimum, and we're going to take our x variable right here, the one we're interested in, and use the Box-Cox transformation. This is going to transform it right here and auto-plot it, and we can see what it looks like. Oh, we didn't select. Look at the errors. We can stack some errors right here. Boom. Gonna make errors when you code. Does it look any different much? Yeah. I'm not gonna comment on it too much. Yeah, Box-Cox is, remember, the Box-Cox can achieve for you many sort of transformations. And the reason we use this is because it can mimic a lot of these right here. Like it can do the square root plus natural, plus linear transformation. So it can do a lot of these, and we don't have to like kind of search through it. So it is doing like a fraction, which is maybe more like a cube root. We don't have to focus on too much what it is, but we could try right here a mutate on it. So, or we could just try changing how we're auto plotting it. So here, let's compare the two. Let's just go to the auto plot of the GDP, and let's do GDP raised to the 1/2. Go away. Really? Oh, because I got an extra one. Do I? Okay, good. Whoa, that's 5 minutes. So what you probably want to do. There we go. Okay, watch this. I think this would work. So here's some cool ideas for you right here. Okay, so this is preliminary work to find out. We could leave that. Here's the first plot. Once again, coding's a lot of copy pasting. So this code right here finds lambda value. Lambda value is the optimum value that we will use to do the Box-Cox transformation. So finds optimum value of lambda. And then right here, we have no transformation. Then here we have optimum lambda. And here is, last but not least, square root. Square root transformation. So, transformation. We're going to do Tiffany's question next here. Thank you, Tiffany. So here's a good idea. This is the last one I'll do on this, because par... No, info. Okay, wait. I want to do one last thing here with this, make it look all pretty. Change how many plots. Phone is ringing. Par, here it is. It's par and flow. Here it is, found it. I always get this wrong. Such an easy code, and then it just jumps out of my mind. Rows, columns. Here we go. 1, 3. So watch this, Snare. Oh, really? No. Really? The auto plot won't do that. Okay. Auto plot's going around the parm flow. Let me look at one last thing right here. I want to make this look all pretty. Make our plot to... Okay, I think we want to use... Okay, here it is. Oh, no, we got this. Watch this. So require grid extra. That loads it up. I think require, if I understand what require does properly, if the library is not loaded, it will load it. So we want to call this G1. No G4 today. Only G Fuel. G2. So now I'm storing these graphics as a graphic. We need to take this code right here, bring it down to the end of this. And with this right here, we've got all these plots saved. And then grid arrange should do it. Number of columns, 3. G1, G2, G3. Object G1 not found because we didn't store these objects. Boom, 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 boom. There we go. And what I would then do, so let's finish it up, make it look really nice right here. We need to go right here and take the following titles and add them and say lambda transformation. And then here we take this and say no transformation. Oh, let's run the chunk. And there we go right there. There we are. So, and then you want to talk about these. So I won't talk about these. Yeah, and so you can take your own screenshots or you can just let it knit into the document. But this right here will give you a, I like it kind of like this right here. I might even, so you can, talk about what these transformations are going to achieve. And you always want to be thinking about how you can visually present these and what you can do. You want to make sure you're adding titles to stuff. That's always good to do. It's not that hard with the GG title, just add it in. And we can get some pretty nice output here pretty quickly. And so, Snea, how's it looking? Oh, no, hopefully it's not too hard, DK. It's a lot of fun. I love this kind of stuff. And Snea and everyone's doing excellent. It's all about that practice. It's all about that practice. But yeah, I think Tiffany had the next question, but I love doing this kind of stuff. It's a lot of fun to make these graphics and just to see what we get. But yeah. Awesome. Let's check it out. Okay. Next question. Here we go. Yeah, so that was some excellent work right there. Yeah. Shiny's a lot of fun. And then I think coding's fun. Like, I actually find coding to be relaxing when you get to work. There's so many little things to remember and so many things just to do. That was BAS 475 time series. So we were looking at some time series plots of the GDP of the United States right there. Is it time to go for you in 4 minutes? Oh, no. Yeah, technically I think, but we're going to keep going. We're fine. We got time for your question, Tiffany. The question was chapter 13, right? Which one was the chapter 13? Brian got his energy back for the moment. What chapter 13 question was it again, Tiffany? And for me, it takes more medicine in like another 30 minutes. So sampling distribution for and so which question is it? Yay! Thank you. Yeah, I'm doing a bit better, and doing a bit better. Last night was a little rough. Woke up quite a few times, but just want to be 100% again. It's always our goal. So here, chapter 13. And sampling proportions. Oh, wait, I remember now. It's the waiter, waitress. No, it's the bank question. It's the bank one. It's about banks. Oh, it's on the homework. Let's do it on the homework. It's on the homework. I know that for certain. It's the bank problem. Let's go look at the bank problem from chapter 13. Let's take a look right here at the bank problem. Okay, let's do this. Chapter 13, bank problem. Here we go. So, based on past experience, the bank believes that 9% of the people who receive loans will not pay it on time. Now, once again, this question is all about notation. And so we do have stuff from the last time we solved one of these. It's the last one we solved where we did the notation. So let's go here and let's take a look at it. Here's all our notation from the last problem. Now, what I'm going to do for you is I'm going to show you that these problems that we did one earlier are very similar. We are literally going to identify the same things again. I should leave that categorical up there. Really? Okay. We're just solving for all this again. So we're solving for all of this again. It's kind of like our template for these categorical questions. Why is it categorical? Well, a bank is trying to see if people pay their loans on time or don't pay their loans on time. That's a yes/no question. So there's the question. So what is P? We're back here on the same steps. So what is P right here? P is the true proportion. It means this is the actual. So the question is, what percent of people actually don't pay their loans on time? So a bank believes this. So what is P right here? P is the actual truth. 9% is P. Yep. So that's P right there. And that makes N right here this. This is the sample size. It's how many we speak to. That's how many we spoke to. And then if we know P, what else can we find, Tiffany? If we know P, good thing to know. If we know P, what else can we find? And these are equations that we will use always to solve these problems. If we know P, what else could we find? If we know P, what else could we find? If we know P, what else could we find? So P, correct? And then, so what else can we find from P? What other, like, notation thing? Q is close. It might be for yours. Might be for yours. That your problem might be slightly different. There we go. And so Q, yeah, no worries. Tiffany, 100 points right there. You great job. Excellent work. Q is 0.91. It's just the complement. So how do you know what P and Q are? Once again, they always add up to 1. So if P is 0.09, you can just go to 1 and subtract. And what does complement mean? It means something plus something else add up to 1. So the way to check your work on this is just to say, do these add up to 1? And then you found P and Q. So P is the true proportion and Q is the complement of the true proportion. And so now we will take and we will do P times Q over N square root. And this finds for us the variation in the problem. That's P times Q over the sample size, square root. We'll solve that in a second. And now the top part of this problem, just think about this, but don't think about it too much. If the bank expects 9% of people to not pay loans on time, and they give loans to 500 people, what percent of people would they not expect to pay their loans on time? If the bank expects 9% of people to not pay loans on time, so what percent of people would they expect not to pay their loans on time? If banks expect 9% of people to not pay their loans on time, then what 9% of people not pay their loans on time? Then if they took a sample, what would they expect from a sample? This just says, what they would expect 45, but this is going to be the sample proportion. You are correct. They would expect 45 people. Great job, Tiffany, right there. They would expect 45 people, but they would expect, which is 9%. Now, I know 9% is the truth, but remember, this is equal to P. That's what we have right here. The true proportion is what we expect. 9% of people are expected to not pay their loans on time. So if I take a sample, I'd expect to see 9%. That's what this says right here. The mu is the mean, which is the expected of the sample proportion. So I'd expect in a sample to see 9% of people not paying their loans on time. So that's got that right there. And that's the mu. Let's go check it out. So I'd expect 9% of people not pay their loans on time. And that's what I expect to see in a sample because we know 9% of people don't pay their loans on time. Do we know that? We believe it. And so the standard deviation right here, they're using SD. I like to use sigma for it instead. So you see I wrote it here as sigma in all of my equations. Here's this equation. So now we need to go here and find out the standard deviation, which is P times Q over N square root. And so let's go here, P times Q over N, and then square root the whole thing. It's not P times Q over N square root. It's P times Q over N square root of whole thing. And that is the variation in this. That is the, like, it won't be always 9% of people not paying their loans on time. There'll be variation around it. So 9% plus or minus this variation is what we have right here. And that's the variation, 3 decimal places. One second. So that is the variation around this. That is the 9% plus or minus about 1.3%. So we could be off. Oh, the P times Q over N square root. Do you have your P? Do you have your Q? Do you have your N? Do you have your P? Do you have your Q? Do you have your N? Do you have your P? The P times Q over N square root. Do you have your P? Do you have your Q? Do you have your N? And then make sure you do P times Q divide by, okay, then so make sure, I can double check your work for you. Just want to put in the thing. If you show me your P, the Q, the N, I can double check for you what the P, the Q, the N is. So P times Q over N square root. And so that'll find the standard deviation right here. So the P times Q over N square root. Make sure it's square root of everything though. Uphill, don't square root at all. P times Q over N square root. That looks, but then yeah, square root the whole thing. Yeah, make sure to do P times Q. Is your sample size 100? It could be. It could be. And then square root. There you go. It could be 100. I think I've seen 100 for this problem before. P times Q over N square root. P times Q over N square root. So you should get this right here in the 3 decimals. That's going to be 0.034. 0.034, I believe. Should be that right there. Double check. Should be that right there. Sorry. All right. Here we go. Next part of the problem is about conditions. Condition 1. Oh, man, do I still have this? Oh, from last semester. Let me go grab this. Condition 1. Oh, thank you, people are posting in the chat. I love it. Let me go grab this. Super important stuff. Doing a little bit better. Okay, let me go grab this. Very important thing we're about to see. Posted this a ton last semester. I'm almost to it, I think. Ooh, where is it? Oh, we've had so much this semester. That's so good. We didn't delete the stuff from last semester, did we? I think we did. Let me go to the archive. Wait, we're so close. Oh, we did delete it. Let me go to the archive channel. Oh no! Did we just delete the channel permanently? Oh man. It's a bummer. Let me get this. What do I do? I round it to 3 decimals, to 3 decimals. Let me go find this. I want a picture of this. They're so close. What? My YouTube thing. Let me go to last. Okay. Show the conditions at all times. I want to find the picture of this so we can keep reusing it. Should have just saved it. No. One more try. Brian, why not show the conditions? Okay. So condition 1 is random. We need to randomly select these individuals. So did we randomly select them? Maybe. Condition 2 is 10%, and these will always be the same conditions. I'll find this picture here in a little bit. But condition 2 is 10%, and we need to select less than 10% of the population, which 500 people would probably be less than 10% of the total bank people. And then condition 3 is going to be success failure. We need at least 10 successes and at least 10 failures. The way to figure this out is NP needs to be greater than or equal to 10. So N, which is going to be 500, times P is greater than or equal to 10. And then we need to have NQ, which will be N, which is sample size times 91, is greater than or equal to 10. So with reasonable assumptions, it's met. Was it random? Is this less than 10% of the population? Probably all those good things right here. And so we did. I should have a test review, and the test review should have it. Final review. Okay, it has to be in the final review. I want to post this picture. What are you confused on, Tiffany? There's no way I didn't review conditions in here. What? You love talking about conditions, Brian. Which part are you confused on? Try to find it here. Just taking a moment. This graphic is very important. I probably could have just remade it in this amount of time. The part B? Which part again is part B? Oh, no, usually with reasonable assumption. How many successes do you expect? While I'm working on this, Tiffany, how many successes? Remember, it's NP needs to be greater than or equal to 10, and NQ needs to be greater than or equal to 10. Once I get this graphic, which we'll then use for the rest of the semester, I mean, it's so pretty last semester. And then we deleted the channel that had it in it. There's old Brian right there. Should be in the... Do we make it over the summer, maybe? Exam 1 review. What will be your numbers? With your different numbers, what will yours be right there? Here we go. Oh my gosh. What the heck? I can't find it. I used to all the time. The longest solve ever. So then you want to do NP. I'll write in the chat. You ready? NP greater than or equal to 10. NQ greater than or equal to 10. What is your NP, NQ? And are they greater than or equal to 10? So your NP, your NQ both need to be greater than or equal to 10. So do you pass that condition right here? What is your NP, your NQ? Are they both greater than or equal to 10? So, well, no, it needs to be NP. It needs to be NP. So what is NP for you? So your NP and NQ both need to be greater than or equal to 10. So what is your NP? Which is your sample size times your sample proportion. So what is your NP? What is your NP? I might find it. So what would NP be, though? my gosh. Can't find it. So yes, exactly. And that's greater than or equal to 10. Took a long way to do it. That's greater than or equal to 10. And so now that we know, so check answer. Now that we know this, so now what we're going to do, I've done a horrible stop on this question because it's taken way too long and gone way too sideways just to find the condition review. What we need to do now is we need to draw the sampling distribution. To draw the sampling distribution, the easiest way to do this is to go to the David M. Lane. Now, what this question is asking is what is the probability that over 11% of people will default on their loans, not make loans on time? And so when we look at this, when you think about what's going on right here, 9% is what we expect, and we're wanting to see over 11%. So when we go to the David M. Lane applet, we're going to put in the mean and the standard deviation. Mean and standard deviation. So you'll put your mean and your standard deviation here, which you found, and then you want to find above 11%, because this is showing you the probability that more than 11% of people would not make their loans on time when we expect 9% of people to not make their loans on time, and we have a standard deviation of 13.13%. Yeah, that's right. So this is what we would expect given 9% of people don't pay their loans on time with a variation of 1.3%. We would expect about 6.2% of the time from a random sample of 500 people, and yours probably will be higher. It just depends. But make sure just to plot if it says less than or greater than. But does that make sense, Tiffany, right here? That we would expect 6.2. And let me, while I pause on this screen, so I'm going to keep the screen paused up here. And I'm going to try to find it because I should have this. I should have it. It's going to be further back than September. Oh, man. Do we have the archive channels? I really want to find this. It's like I dreamed this up that I wrote the conditions out. I don't know. So this will be our answer right here. For a mean, so that's where your mean goes. That is the mean, the mu we found. This is the standard deviation right here. And then this is the above right here, which is we're saying above 11%. So we're asking what is the probability that above 11% of people would default on their loans? Did I lose the question? Oh, it's on the other page. When we would expect 9%. Yeah, okay, I'll do that right here. You got it, Tiffany. Check. Okay. So using those numbers, your mean is, so 13% of people are expected to default, standard deviation of this. And then we want to see above, as long as it says above. And so here we go. We're going to do our brain work. Ready? It's going to be about 13.8%. It's 12%. Close. So more than one standard deviation above. So you should put in whatever this rounds to, Tiffany, say 3 decimals, so 0.112. It's got that right there. I'm probably going to head off here, but I need to find that conditions. I don't know where we're at. Or rewrite them out, but I had them written out so nice. Condition 1, random. Condition 2, less than 10%. Pause. Let me do that one. Mine say, what is probably over? Yep. And so this is it right here. I'm going to head off. I'm going to grab some more coffee and some more medicine. So, well, I should wait another. I have to take medicine during class. Awesome. Yep, that should be it rounded. Yep. Awesome. Well, let me know if there's any problems. We'll be back here probably later today. Probably. Hopefully. I'll see everyone later. Bye for now. Bye.